Okay, now we're going to do part C. For x is not equal to 3, the function of k is defined by k of x. So now this is a new function, but it involves the derivative of the graph shown and the actual function f of x. This is a quotient. It is known that the limit as x approaches 3 of k of x can be evaluated using L'Hopital's rule. So what does that tell us? It tells us that we know that the limit of the numerator as x approaches 3 is 0, and the limit of the denominator as x approaches 3 is equal to 0. So find f of 3 and evaluate the limit as x approaches 3 of k of x. So the first thing that we need to do is find f of 3. Well, f of x is in the denominator here, and we know that this as x approaches 3 has to be equal to 0. So that's why I set it equal to 0. And now I'm going to plug in 3 for x. So 3e to the 2 times f of 3 plus 5 minus 3 equals 0. Okay, so for all the x's I plugged in a 3. Now I'm going to add 3 to the other side and then divide by 3. And so if I do that, and do that in 2 steps, e to the 2 times f of 3 plus 5 is going to equal 1. Right, so you see that? I added 3 to the other side, then I'm going to divide by 3. Okay, now how do we get something out of an exponent when we have e? Raise both sides to the natural logarithm. So the ln of e to the 2 times f of 3 plus 5 equals the ln of 1. And we know that the ln of 1 is equal to 0. And that means 2 times f of 3 plus 5 equals 0. And now let's solve for f of 3 because we're trying to find f of 3. Sorry about the focusing thing. Okay, so 2 times f of 3 equals negative 5. F of 3 is equal to negative 5 halves. So there's your answer. F of 3 equals negative 5. Okay, now I'm going to find the limit. So L'Hopital's rule says that we can take the derivative of the numerator separately and then take the derivative of the denominator, provided we get indeterminate form, 0 over 0. We don't have to check that here because they already told us that L'Hopital's rule can be used. So we know it's a 0 over 0. So we're going to take the derivative. And remember, I always like to use a little L here. The limit as x approaches 3. I'm going to take the derivative of the numerator. Well, this part of it here, when you take the derivative of the integral, is the second fundamental theorem of calculus. So when you take the derivative of it, remember you replace t with your upper bound, and then you take the derivative of the upper bound. And then, of course, we have this extra constant coefficient. So the numerator is going to be 3 times f prime of the upper bound times the derivative of the upper bound, which is 3. And now take the derivative of minus 4x, will be minus 4. Okay, and the denominator, if I take the derivative of that, taking the derivative of e, so remember it's e raised to that power times the derivative of that power, chain rule. This is going to be 3e to the 2 times f of x plus 5 times the derivative of the exponent. So it would be 2 times f prime of x plus 0 minus, that was supposed to be an x, so minus, right here, take the derivative of x, so it's minus 1. So that looks quite complicated, but it's testing your knowledge of the second fundamental theorem of calculus, if you know the chain rule, and if you know limits. So now we're going to evaluate at x equals 3. So we take the derivative. I'm going to evaluate. Now, if you did evaluate at 3 and you got 0 over 0 again, you can use L'Hopital's rule again, but that's not going to happen here. So that's going to give us 3 times f prime of 3 times 3 is 9 times 3 minus 4 divided by 3 e to the 2 times f of 3 plus 5 times 2 times f prime of 3 minus a 1. Okay, so we want to get a little bit further now. So we need to know what f prime of 9 is. So let's look at that graph. Remember, this is f prime. F prime of 9 is 0. Right? When x is 9, y is 0. So f prime of 9 is 0. So it's going to give us 3 times 3 is 9 times f prime of 9, we know that's 0, so it just ends up being 0, minus 4 divided by 3e to the 2 times f of 3. Well, we just found that earlier. F of 3 is negative 5/5, 5 halves, so plug that in, plus a 5 times 2 times f prime of 3. So again, we need to go look at the graph. At x equals 3, y is 3.5. So f prime of 3 is 3.5. So times 3.5 minus a 1. Alright, let's continue. So this is going to be 0. Numerator is minus 4. Denominator is going to be 3 times, this becomes 2 times negative 5 halves becomes negative 5 plus a 5, so it's either 0 times 2 times 3.5 is 7 minus a 1. So that ends up being minus 4 over, this ends up being 21. Minus 1 is 20. Which is negative 1/5, but remember on the calculus exam, you can leave your answer in unsimplified form.